Okay, so we said we were going to check whether A and B here were perpendicular. So let's first of all find the components. So A has the components 6, 4. And B has the components -2, 3. So, what is the scalar product of A and B? Well, that's 6, 4 times -2, 3, which is 6 times -2 plus 4 times 3, which is -12 plus 12, which is equal to 0. So yes, A is perpendicular to B. And we're done. So, we know how to investigate whether two vectors are perpendicular given their components. Let's have a look now at a different type of exercise. In your book on page 233, you'll find exercise 12.91, and we'll just have a look at part A. And it asks you to find two vectors that are perpendicular to A. And in part A, our vector A is equal to 1, 4. So we need to find vector B and vector C that are perpendicular to A. So we could go about this by saying, well, B is equal to B1, B2, and we know that A times B, 1, 4 times B1, B2 has got to equal to 0 if they're going to be perpendicular, which means that the components B1 and B2 have to satisfy the equation 1 times B1, or B1, plus 4 times B2 is equal to 0. And you could pick then any B1 and B2 that satisfy this equation for this exercise. And if you notice that if you put in B1 as 4 and B2 as -1, then that would work. So we could have vector B as being 4, -1. And that actually always works. If you flip the components upside down and make one of them negative, then these two vectors will always be perpendicular to one another. So, A2 negative A1 and negative A2 A1. So we flip them and we've made one of them negative in both cases. They are always perpendicular to the vector A, which would be A1, A2. So of course, another vector we could have would be here, -4, and here, +1. But we can also take multiples of these. We could take the vector C as being -8 and 2. Because if I put -8 and 2 into this formula, -8 plus 8 would give me 0. And I could also halve these if I wanted to. I could multiply this by any scalar I wanted to. So for any r that's not 0, multiplied by b, I would also get something parallel to b, which would be perpendicular to a. So this is just another little thing to remember. If b is perpendicular to a, then for all r in r star, so the real numbers without 0, r times b is perpendicular to a as well. Because b and rb are parallel, and so they must have the same relationship to a in terms of whether or not they're perpendicular. So, that's all I wanted to say about parallel and perpendicular vectors. Hopefully that was all clear. As usual, if you have any questions, put them in your book, note them down to ask in class, and we can hopefully sort that out together. Otherwise, I'll see you in class.